Good morning, everyone. Thanks for attending our first ever workshop. I'm Roberto Vannoci. I'm responsible for multi-sectoral research and innovation department of Centro Cotta. Centro Cotta is a textile technical center located in north of Italy and is the coordinator of the REACT project. I thank you for participation. I thank the project officer for of the REACT project for his participation and also the speaker as well. Just a few slides from my side in order to introduce quickly and brief the project. You have already seen a video without any speech or without any sounds. Okay, thanks Galileo. And then the next one, we start immediately. We'll have just a few presentation by me, then an intervention by the project officer, the speeches by the speakers, and of course at the end the question session, as Galileo said. So please post your question by the chat. REACT is research an innovation research and innovation action under the Horizon 2020 program focused on recycling acrylic fibers and used for awnings, tents, outdoor textile products. The main objective of the project is to remove chemical substances that we can find in the fabrics due to properties that we want the fabrics and the goods made by the fabrics have, such as waterproof or repellency or perhaps antimicrobial characteristics. These substances can be hazardous if released without control in the environment. So the idea is to make a system, a process to collect all the used fabrics, remove these chemicals before going to the recycle, the mechanical recycle. Next one, please. Okay, we have some targets, very challenging in some cases, in some other natural challenges. We want to collect at the end of the project at least 5% of the acrylic textile waste. We want to remove more, at least 90, but more 90% of chemical substances over the fabrics, and if we succeed, as we think, I have to say, we look at transfer this technology to other sectors. Other sectors means other kind of fabrics, substrates, and so on. Please, Galileo, the next one. Okay, this is the action that are foreseen in the REACT project. So we study how to collect, to sort, to test, classificating so the textile, the waste acrylic textile, how to eliminate, how to treat the waste or the sludge coming from the removal of finishing chemicals, and with the fabrics without chemicals, how to recycle, mechanical, and then to spin and to finish and to respin and to have another prototype of new products, perhaps in the same let's say application, or for others with this secondary raw materials obtained by this process. Of course, all these activities will be evaluated in order to evaluate in particular the impact, the economic aspects, and so on. At the end we'll have a recommendation how to use what we studied. Next one, please. This is the last one, the last slide with all partners. So Centrocotta, as I said, the coordinator. Martel, this is guessing the workshop is for the communication, dissemination activities. Then Ghent University, CETI, that the French, Ghent University from Belgium, CETI from French partner for recycling, soft chemicals for the chemical parts adding removal, and also in study eventually new low impact finishing, and YAC, the spinning mill, and the Tempo Test or Para, the company that's producing fabrics for awnings and tents. This is the REACT project, and so we think that we are more or less half an hour, 1.5 years of our project in the middle, and we think that we are succeeding quite well, as we try to say during the next presentation. I finish from my side. Thanks. And I give the floor to Mr. Yannis Koglitz. Sorry for the pronunciation, Yannis. That is the project officer that will say us some about, of course, the Horizon 2020, but in particular the next goal, and where we can have other interesting things. Thanks, Yannis. The floor is yours. Okay, Yannis.
Do you hear me now?
Oh, yes.
Yes, hello? Okay.
Yes, thank you.
We went see you. Perfect, thanks.
Okay, thank you very much, Roberto. I'm very happy to join you in this webinar. I'm, first of all, to introduce myself, I'm Yannis Koglitz. I'm working in EASME. I'm the responsible project advisor of REACT. In EASME, we are implementing research and innovation actions on the Horizon Europe program, of the Horizon Europe program. In my unit, we are working on the circular economy related innovation support. And in this context, REACT was selected. I would like to give some background on the current developments since REACT was selected at that time. It was a time where we had the circular economy, the transition towards a circular economy, and it was the support towards this transition via innovation projects, and this is the case for REACT. And while in the meantime we had a change in the political environment, we have put with the new commission the policy of environmental protection and circular economy is more in the heart of the commission. We have the Green Deal, the European Green Deal policy, which is the umbrella policy putting forward a huge number of actions related to environmental protection. And under this umbrella, political umbrella, is also the circular economy policy. Why this is done is that this is done as just to give a background. As most of you from the project know, only 12% of the materials from industrial uses is sent back for recycling, and that's one of the main reasons that the Commission wants to mobilize industry for a green circular economy. One of the main points that innovation and actions will be supported is the circularity in production processes, as up to 80% of the environmental impacts can be avoided, are related, and can be handled at the design phase. In this context, there are two main strategies proposed from the Commission. The one is the Green Products Initiative, which is currently under the phase of the inception impact assessment consultation, which will end on the 9th of November. And within this initiative, there is a clear link to a comprehensive EU strategy for textiles. The Green Products Initiative is, in fact, will look on the eco-design of products and will look on expanding and amending the eco-design directive of energy-related products to address circularity and environmental protection aspects on other product categories, including categories of high interest, like plastics, packaging, and textiles. Regarding the textiles, a new sustainable product framework, including eco-design measures, will be developed. Guidance to ensure by 2025 a high level of separate collection of textile waste will be provided, and different initiatives to support to create new circular business model will be proposed. In parallel to that, and very relevant for the REACT project, is the chemical strategy for sustainability, in which exactly 2 points on non-toxic material cycles and on design issues will be looked for. There will be a development of EU safe and sustainable by design criteria for chemicals. And there will be also actions to minimize the presence of substances of concern in products. And in parallel to that, we have information on chemicals content and safe use, authorized and derogations, and methodologies for chemical risk assessments. So there is a lot of activities and a lot of, I will dare to say there is an orgasmus of policy development in the area of eco-design of products like textiles and of chemicals, use, presence of hazardous chemicals, and removal of them in order to make the transition towards a circular economy. And I will see projects like REACT to be one of the first in the round to showcase examples of innovation, where then in the near future will be later developed other projects, and will even bring all these ideas and solutions into the market. And having said this, I will put a stop here, and we'll wait for any question from your side and any reaction maybe to discuss it. Thank you very much.
Thank you, Yanis. Okay, we have 2 messages from you. One is okay. We must have a look at European Green Deal. Call yes, sure, and for the topics you suggested, and also that I thank you for the information, and that React is one of the first project looking at removal of finishing. This is good news for us. That means that we are on the edge of the innovation for textile or for plastics in general. Thanks for your words. If you have any comments during the or suggestion or question during the presentation, please ask the other participant ask us, and we'll try to answer. Okay, then we go to the presentation. The first one is Daniele. Mr. Daniele Piga received a PhD in chemical, geological, and environmental sciences. He has gained a significant experience in the plastic sector, and now he's a researcher at the Multi-Sectoral Research and Innovation Department at Centro Cot, and so we'll have his speech. Please, Daniele, sorry, the floor is yours.
Thank you, and hello everyone, and thank you for the participation at this first workshop of React project. The React project studied the recycling of acrylic textile waste for the outdoor. Is a very small market segment, but which has problematic that today make difficult the recycling operation. Indeed, the recycling waste in textile sector are strongly influenced by the diversity of materials and end uses. They range from the clothing and clothing accessory to technical materials such as the personal protective equipment and so on. For a global market valued at just under $1,000 billion last year, with a predicted increment of 4%, around 4% in the next 7 years, and with only 1% of the market made by the recycling products, a very low value. Focusing on technical textile sector that including transportation, protective clothing, furniture, and so on, the most of fabric have a chemical finishing to increment the performance of fabric in order to comply with the need of use. This finishing make more difficult and problematic fabric recycling, because if they recycled with common mechanical techniques currently uses in textile sector, give a recycled product with lower purity than virgin. Among technical fabrics are present the sector of for awning and outdoor furniture, on which the project is focused. In this sector, the acrylic fiber is still the most used. Over the 90% of outdoor fabric production is in acrylic, despite it is more expensive than other fiber like polyester. This is because the acrylic fiber have a matched performance deriving from a combination of weatherability, UV, and mechanical resistance that need a lower finishing application than other fiber to reach the desired performance and ensure many years of use. For this reason, the world production amount of acrylic fiber for outdoor uses is estimated about 11,000 tons for year, with an estimation of 2.5 million awning installed only in the Europe. This means that the production and use generate little less 8,000 tons for year waste in Europe, which are incinerated or disposed in landfill. As we have seen, the main problematic in the sector are the added chemical, and the goal of REACT is remove these undesirable and hazardous chemical with the most economical and ecological way possible, which could give a new market opportunity for producers to improve the sustainability and reduce the environmental and health risks. In particular, the removal process we are developing will allow rate removal undesirable chemical more than 90%, producing a final recycled product with high purity, further increasing the recycling yarn production through the mixing the treated acrylic fiber developed in the REACT with regenerated acrylic fiber, with the goal to prevent the 30% of acrylic waste that's disposed in landfill at the finish of the project. Moreover, to increment the sustainability, the sewage generated during the chemical removing process will be treated with the IM to reduce the polluting rate and bring the chemical oxygen demand and biological oxygen demand value under the regulation level to assimilate them at the municipal wastewater. Therefore, to obtain a high purity recycled material is important to identify the finishing composition. In the project, we identified 3 main different finishing for outdoor uses that are for awning and umbrella, called finishing A, waterproof fabric for marine uses called finishing B, and for outdoor furniture called finishing C, which contain a different kind of chemical, and it is therefore essential in the project development methodology to separate the fabric with different type of finishing before carrying out the chemical removal process, with the aim to obtain a high purity acrylic to introduce in the common mechanical recycling process in the textile sector, and they produce an awning recycled prototype to test. For this reason, in this first part of the project we sorted the waste arising by all production chain and by the end of life in different categories, on the right of the slide. In the left side, the waste generated for the production of fiber and yarn before the application of finishing, from which we produce the regenerated fiber. In particular, the regenerated fiber. In the right part of the column, the waste arising for the production, the quality control, the customer, and the end of life, and are present the finishing. In particular, the post-consumer product have a whole series of unknown substances that can deposit and form during the period of use, depending on various environmental and maintenance factors. To overcome this indeterminacy of substances present on fabric, we developing a sorting protocol based on near-infrared spectroscopy, on which are based the common automatic sorting for plastic, enhancing it with a chemometric approach, creating a method based on near-infrared spectroscopy that identifies not only the kind of finishing on fabric, but also the concentration and eventually the presence of other chemicals, faster and with no destructive method, in order to separate the acrylic waste and use the best removal process method for any fabric. The database generated in this part of the project will have a dual purpose. Indeed, the finishing removal method effectiveness will be assessed with common technique, and at the same time with the near database, creating the sorting step. This will lead to the implementation in the developed system of a near automatic forecasting method and model to identify and compare cleaned waste with original fabric. The identify removal process will be scaled up at pilot industrial plant with the appropriate modification to verify the reproducibility with higher amount of fabric and obtain the amount needed for the mechanical recycling and weaving in order to produce a prototype of recycled acrylic owing that will be tested. The removal method on scale-up will be deepened after my presentation by partner. The removal of chemicals, of course, lead a positive impact of recycled material purity in the owning sector. Indeed, will be removed at least the 90% of chemical on fabric. The purity of final product will be incremented with the mixing of recycled fiber with regenerated fiber, opening a new market for acrylic, but not only. Because we will evaluate the possibility to extend the technology developed at other kind of fiber and on the sector with similar problematics, such as the personal protective equipment. A particular case is that in this pandemic situation, the mask. The mask could be a finishing very similar of the owning, and with this method developed in the rack, we could be remove this finishing. Moreover, environmental and health risk will be lower by reducing the hazardous substances in recycled product and prevent their landfill disposal. Finally, if you would like to know more, you could follow project result from LinkedIn and Twitter account and the website where you could subscribe to our newsletter. Thank you.
Thanks, Daniele, for your speech, for your presentation. As you all can see, the objective, the figures, the KPI, the key process indicator or performance indicator are very challenging in some cases, but of course, I think this is all for the Horizon 2020 projects. Don't worry about the figures and the numbers that we are showing, because the presentation will be available on the React website, so you can look at carefully and with more calm in the next time and the next days. For any questions, please post in the chat. In the chat also you have all the information that the project officer presented us, so the link to the main documents of the call he spoke. The next speaker is Josephine Geldmeyer. Josephine Geldmeyer received a PhD in materials engineering from Ghent University in 2017, and now she's a postdoc in the Department of Material, Textiles and Chemicals Engineering at the Ghent University, of course, in Belgium. Her speech will be about the solution for the crucial challenge of textile recycling, that is how to remove chemical finishes from acrylic fabrics. Thanks, Josephine. Please have your speech.
Josephine, unmute yourself.
Oh, my apologies. So good morning, everyone. Thank you for the kind introduction, Roberto. I'm Josephine Geldmeijer, postdoc at Ghent University within the Center for Textile Science and Engineering in Belgium. And one of the projects I'm just working on is the REACT project. So today in my presentation, I will present in a generic way the work our research group performed on the removal of the finishes from the acrylic fabrics. As introduced before, the goal of the REACT project is the recycling of the waste acrylic textiles from outdoor applications. And this waste was classified in 3 types, namely fabrics for furniture, coated waterproof acrylic fabrics, used, for example, for boat coverings, and then finally fabrics for awnings and umbrellas. And this last type, the fabrics for awnings and umbrellas, will be the focus of my presentation. So in the REACT project, it is the first aim to remove the finishes from the acrylic fabrics, after which mechanical recycling follows up to the fiber level. So the fabrics will be opened up until the fiber level, but there's no further downward chemical recycling of the fibers up to polymer or even monomer level. And one of the crucial questions we ask of ourselves, of course, and which is already introduced by the other partners as well, is why to recycle? And in general, there are 3 main reasons for this: the ecological benefits, the economical benefit, and the health benefit. So first of all, the ecological benefits in general for textiles, life cycle assessments have shown that the promotion of reuse and recycling has the highest impact on the availability of resources and human health. And also the damage on the ecosystem diversity is highly improved by reuse and recycling. And one of the points which, of course, interests us a lot is it is also reuse and recycling that is the most promising option to decrease the contribution to climate change. Secondly, there is also an economical benefit, and a significant amount of energy is conserved by recycling. And in addition, literature has shown that acrylics have the 4th highest recyclability potential index. And this recyclability potential index takes into account both the environmental and economical considerations. And then finally, since the fiber production process is no longer repeated, there's also a significant health benefit. The melting temperature of acrylics is above the degradation temperature. So therefore, the fibers are solution spun in highly polar solvents such as DMF and DMSO, which are toxic chemicals. And by avoiding their use, we also have a significant health benefit. But despite all these benefits, the textile recycling is still rather limited. And for example, for clothing only 1% there was closed recycling, and up to 12% of clothing is downcycled. For outdoor acrylic fabrics, they are at the moment not even recycled at all. So if we go back to the REACT methodology, the next slides will focus on the step of the elimination of the finishing of these chemicals. And that is where we find a problem. Why is recycling not yet done for these acrylics? And that's because of the chemical finishes which are on the fabrics, which need to be removed first. So the awning finish consists of a thermosetting resin and fluorocarbon resin, which surrounds the fibers. The fluorocarbons are the most used water, oil, and dirt repellents because of their low surface tension. And the thermosetting resin improves the dimensional stability, heat resistance, and wash fastness of the fabrics. This thermosetting resin physically surrounds the fiber surface, and it also, we believe it to bind the fluorocarbons to the fibers as well. Unfortunately, the cross-linked resin is insoluble in any solvent, and that is why our strategy is to reverse the reactions by cleaving the covalent bonds of the cross-linked network. So how do we evaluate this finish removal? Fourier transform infrared spectroscopy lets us identify the chemical signature of our fabrics and finishes, and an infrared spectrum of an uncolored unfinished acrylic fabric is shown here together with the characteristic peaks. So the finished components, they have their own characteristic peaks. And if we then follow the changes in their peaks, we can follow the finish removal efficiency. So the yellow curve is the untreated finished textile. The red curve is the unfinished textile. So this is just the goal we want to achieve after our removal process. And then the blue curve is an example of a finished textile after our chemical treatment. In addition, evaluation of these peak changes requires normalization, and therefore the carbon-nitrogen stretch peak was chosen, and this allows to evaluate the change in peak height of the characteristic peaks of the finishes on our awning fabrics. Secondly, we evaluated as well if there's no mechanical damage to our fibers due to the chemical treatment, and therefore a FIBRE was used, which allows to evaluate the mechanical properties at the fiber level before and after the chemical treatment. And then to execute our experiments, we used a design of experiment methodology. First of all, we did preliminary tests to define the parameters we wanted to evaluate and their range for a screening design. These parameters were defined based on literature, but also on lab trials. Then via a definitive screening design, we could determine which parameters are important to the removal process. And we investigated as well in this step the mechanical damage to the fibers. And these results then allowed us to create a model which allowed us to optimize the parameters of the process and to finally perform optimized tests. So as an example of this design of experiment methodology, a one-step process was evaluated for which 6 parameters were tested. And this one-step chemical process resulted in complete removal of the thermosetting resin for some of the runs and partial removal of the fluorocarbons for almost all experiments. And how do we define now those removal rates? This removal efficiency was determined using what I explained before, this change in peak height of the characteristic peaks in the infrared spectra of our samples. And for this process, the impact on the mechanical properties was also very limited. A small decrease of 1 or 2% was noticed for the maximum force and tenacity for some of the experimental runs, which is limited, and compared to the mechanical recycling, this can be disregarded since we expect that mechanical recycling might induce a bit more damage. The elongation at break and modulus stayed the same or even slightly improved compared to the original acrylic fibers. And then this design of experiment approach allowed us to define a model of the statistically significant parameters. Since only 3 parameters were of main importance, a response surface model could be defined. And this response surface model allowed to define different sets of optimized parameters, both for a maximum removal and industrial removal process. And these optimized parameters resulted in the end in a complete removal of the thermosetting resin and a partial removal of the fluorocarbons via a one-step process, which was optimized at Ghent University. So although the fluorocarbons were only partially removed, since we noticed traces still present in the infrared spectra, the fabrics could be wetted again after this process. And the fabrics are thus now ready to be mechanically opened, and new yarns can be produced, which will be able to absorb moisture and will result in the production of the recycled acrylic fabrics. So we are thus now ready to go to the next step in the REACT methodology, which is the mechanical recycling and spinning. I would like to thank you for your attention, and I'm happy to answer any questions in the question and answer session at the end. Thank you.
Thank you, Josephine, for your presentation of the first steps that we are doing since the beginning of the REACT projects and all the problems that we are facing or the technical aspects. You have a question in the chat, please read, and at the end of all the presentation we'll have a session of answers, and so we try to answer to what the audience is asking us. Thanks. The next speaker is Andrea Cataldi. Mr. Andrea Cataldi is Research and Development and Sales Manager at Soft Chemicals since 2009, developing products and auxiliaries with a special focus on textile industry and related projects. The speech that Andrea Cataldi will hold is chemical removing from lab to industrial plant. That is the task, one of the tasks in charge of Soft Chemicals. Please, Andrea, the floor is yours.
Okay, thank you to Mr. Vannucci from Centrocot, and good morning to everyone. As well explained from Mr. Vannucci, I work for Soft Chemicals from 2009, and it's a huge pleasure for me to be here today and explain which is the role of Soft Chemicals in this important European project. So the title of presentation is Chemical Removing from Lab to Industrial Plant. Okay, a little introduction of Soft Chemicals. Soft Chemicals specialize in the supply of chemical products for the textile industry. The special design developed through our R&D encompass all process steps, whether pretreatment, dyeing, or conventional and technical textile finishing. Soft Chemicals can meet any processing requirements for various fibers and textile items depending on their intended use and required performance. In the picture in the below part of the slide, it's possible to see on the left the factory, Soft Chemicals. On the right, our production, our heart of the factory with the reactor to 5,000 kg and 4,000 kg, and other machine. In soft chemicals is present a laboratory, an important laboratory, which capabilities are a tailor-made formulation, chemicals controlled by FTIR spectrum, HPLC flexor detector, compounds design, possibility to create padding, coating, foaming product for application, flame retardancy evaluation, quality control, and waterproof column up to 10 meters. So our lab is really structured to support the action of selling product in a textile market in Italy and outside. Soft chemicals contribution to REACT. Thanks to the collaboration of all other partners, our first goal will be to define methods and the recipes to clean the waste acrylic textile material available for the recycling process. Soft chemicals will be involved to develop specific target machinery for industrial trials, activities, products, and expertise thanks to the knowledge and network in the textile chain. Okay, these two machines are the most important actually for the previous part of the project in order to understand if we are working in a good way. So we have a water column in the left part of the picture and an under pressure machine on the right part. The water column is used to check hydroplancy performances, and just a little explanation for who never seen a water column is an instrument that helps to do a dynamic test, a dynamic method. And this instrument contains an electronically controlled pump, which produces the test pressure in an internal water tank in the lower part of the machine. And the tank is linked to a test head, where in this case it can be located the wasted acrylic and then the acrylic. And after the test has been started, the test pressure is automatically controlled. And the test is over when the water has penetrated the test specimen at 3 different points. So at this point, the test is finished, and high value, it means that finishing is not removed. If value is low, it means that we are working good. Okay, on the right part, the under pressure machine, in which apply receipt in exhaustion method to remove hazardous chemicals from acrylic waste. So in the machine, in the next slide, I show the machine open. So this machine is really important because can replicate the receipt and the treatment that we are going to do in the industrial plant. Okay, this is the machine open, is an under pressure machine to maximize treatment efficiency. Units employ the lead heating technology for precise heating and temperature control, manual dosing option for auxiliaries and change correlation between laboratory and production process, and programmable parameters accommodate many types of substrate for dyeing and testing procedure. Okay, these little black containers is where the acrylic can be treated, and after the treatment is possible to check also with the kit present in the middle of the picture are oil repellency kit and water repellency kit based on isopropyl alcohol and different kind of decani that can help us in understand if the process and the treatment is running with efficiency or not. Okay, and this is the pilot plant. Is an under pressure machine that can reach up to 130 degrees with a liquid ratio from 1.5 to 110. Maximum kg actually are 20 to treat a textile material, but carrying capacity goal is 50 kg. is similar to the machine that I have illustrated in the slide before, because the machine present in our lab work under pressure, work in the same condition up to 130 degrees with the same liquid ratio. So establishing a method, an efficient method in lab is possible to replicate in this pilot plan. That also is possible to consider 2 containers available for different recipes. So in the container A, it's possible to put before starting 1 receipt, and in the container B is possible to put another receipt. So during the cycle, it's possible to dosage chemicals in different time, and it's possible to create a detailed treatment cycle by working on times and temperature. Okay, currently the industrial machine is working on wool tops, but under processing soft chemicals is developing a system for opened fabrics or fried acrylic textile using a specific container. We think after a deep evaluation with all partners that working on fried acrylic will be certainly more efficient than working on opened fabric. So thanks to the partner city, we are doing a lot of tests in order to find the right way. Okay, future goals for this pilot plant: working at higher temperature under pressure using less time, less chemical, and less water. Okay, thank you for your attention.
Thanks, Andrea, for the presentation of facilities and also for the target object to use at the industrial level this what we are developing, the machinery, let's say. I invite also the attendees to give us eventually request or specific questions also about these parts of the industrialization. And after Andrea, I pass to the last but not the least, as we use to say, speaker, that is Omar. Mr. Omar Maski is a researcher at the Multi-Sector Research and Innovation Department of Centro-Cot. He has a degree in pharmaceutical chemistry and technology and a PhD in biochemistry. He is involved in innovative product and process development with a particular focus on new functionalities, production processes, sustainable approaches, and smart textiles. His speech is about potentialities of chemometric approach, as you have heard by Daniele. We are thinking to combine this approach with some detection, some evaluation, and made, for instance, by NIR, in order to have a quick and efficient way to recognize substances, chemical substances over the fabric. So Omar will speak about more on these topics. Omar, thanks, and the presentation is you.
Okay, thank you, Roberto, and thank you also to the REACT project for the possibility to talk during this workshop. Sorry. Okay. As Roberto said, during this brief presentation, I would like to give you some tips, let me say, about chemometrics. Chemometrics is a term with a lot of different possible meaning, but I think that is good for all the audience to start with a very simple definition about what is chemometrics. The term chemometrics was coined in 1971, so we're speaking about chemometrics from a lot of years. The basic definition of chemometrics is the definition that you can see in the second point. Chemometrics refers to the use of specific mathematical, statistical, and logic-based approach in the field of chemistry. This is the original definition because today chemometrics can be used also in a lot of different scientific fields, not only in chemistry. But in the original use of chemometrics, the most representative field of application was the analytical chemistry. So this part of the chemistry that is dedicated to measurement, evaluation of specific properties and performance of materials in terms of chemistry. Originally, the classical application areas of the chemometrics was related to the testing, in particular in the calibration, validation, and significance testing, but also in the optimization of chemical measurement and also to better define and optimize experimental procedures. Another possible classical application was in the extraction of the maximum of chemical information from analytical data. So you can consider chemometrics like a way, a statistical, mathematical, and logical way to obtain more information from an analytical techniques. In particular, in the origin was chemistry, but now it can be used also in other kind of analytical techniques. So chemometrics help us to extract more information from a pool of data that come from analytical technique. And another definition that can help us to better understand what is chemometrics is that this kind of approach is an interdisciplinary field that involves specific aspect of statistics, that is the multivariate statistics, but also the modeling, the mathematical modeling, computer science, and analytical chemistry. So as you can see, it's a sort of combination, an hybrid scientific approach that mix not only the analytical chemistry, but also this new approach related to computer science, or also the new mathematical and statistical approach. A particular aspect of the chemometrics is that among the others, chemometrics is able to push on the potentiality of the multivariate analysis. What is multivariate analysis? It's an analysis where I can take into account a lot of different variables at the same time. So as you can see in this point, I can treat multiple measurements simultaneously during a data analysis procedure. So I don't analyze one variable at a time, but I'm able to evaluate, to analyze a lot of variables coming from an analytical test, analytical procedure at the same time. This approach helped me to obtain a better view of my system, of my problem, of what I'm studying, because I can evaluate all the different variables I have in the system at the same time. This is a very powerful approach that comes from chemometrics. With this last point, I would like just stress on this aspect. Chemometrics, sorry, is not only related to chemistry today, but I can use chemometrics in the solving of a lot of different complex scientific problems. What complex scientific problem means? A complex problem is a problem where you have a lot of variables and you don't have a known correlation between these variables and the final answer of the problem. So chemometrics can help to better understand the system and to solve the complex problem. So this was just a very brief introduction of what chemometrics means. But now I would like just you a suggestion, an indication about the potential use of chemometrics techniques, chemometrics approach in textile fields. I would like to start with an evidence. Today, the coupling of chemometrics approach with near spectroscopy that is related to the spectroscopic techniques that works in near infrared region is very used. And currently this combination of techniques is focused, for example, to monitor identity and quality of different kind of raw materials, but also semi-finished and finished products in specific application fields such as food, agriculture, polymers, pharmaceutical, and organic chemicals. As you can see in this list, you don't see textile, but now I'm going to show you an example that demonstrates that it's possible to use chemometrics also in textile field. And this example comes from a previous project a previous project that Centro Cot performed 2 years ago was the project named Eco-Textile for Fashion, ETF project, that was funded by Lombardy region in Italy. The aim of the ETF project basically was to promote, to facilitate a reduction in the environmental impacts that are related to the chemical treatment processes of textile, in particular of natural fiber, but I will show you in the next slides. The focus of ETF project was the use of a predictive analysis of the textile material properties through the realization and development of chemometric models that were realized starting from near infrared spectroscopy analysis. What this definition means? During the project, we analyzed different samples of natural textile materials, in particular linen and cotton, that were different in specific properties, such as the processing step, so different level during the supply chain of the material, of the raw material, because here we're talking about raw material or very early semi-finished materials. So we analyzed the different products with different processing steps, different impurities level. So if we speaking about natural fibers, cellulosic fibers like linen and cotton as impurities, we talk about, for example, pectins. Difference is also in the production lot, so different lots of production, of course, and also the sample were different also in geographical origin. We started with a traditional chemical analysis for the cellulose and impurities level in the sample, so normal classical laboratory analysis that maybe can use 1 or 2 days to be performed, and this is an important point, as you can see in the next slides. Then we perform near analysis to collect a lot of different spectra from each sample. The results of this analysis, so there's spectra, were then analyzed by a chemometrics approach that elaborate this very large amount of chemical or let me say spectroscopic data coming from the near analysis, and on the base of this chemometric elaboration, we were able to create a model. This is just an example, and now I will try to explain you. This is a result of a specific chemometrics approach that is named principal component analysis, PCA approach of chemometrics. Is just one of the different statistical tools that you can use during chemometrics analysis. Here you can see that all the different samples are here represented, let me say better, all the different spectroscopic results coming from the different samples are here represented in as cluster in a three-dimensional space, an orthogonal space. And in fact, you can see three axes, the PC2, the PC3, and the PC1. So I have three axis, so I have a three-dimensional space, and each cluster in this case represents sample with a specific amount of impurities. The percentage that you can see here is the amount of impurities that we obtain during the chemical analysis. After the reading with the spectroscopy, the spectra coming from the samples were analyzed by PCA approach, and then we obtain this kind of models. Here, the different sample with different amount of impurities is represented in this space, and as you can see, if I move from the top to the bottom on the vertical axis, I can see that the impurities decrease. So I have a spatial, I have a particular position in this three-dimensional space according to the impurities amount of the material. So, for example, if I analyze with the spectroscopic technique a sample that of which I don't know the impurity levels, then I put this result in the econometric model. The system put the sample in the space and near the group of sample with the same impurity level, more or less. So what is the potentiality of this approach? If I have to evaluate the impurity level of a material, and I have developed this kind of models, I don't need to perform a chemical analysis. So I don't need 2 days to have an evaluation of the impurity level of the material. I can have an evaluation that if the model is very good, this prediction, this evaluation is very close to the real amount, I can have an evaluation of this impurity level without chemical analysis, but just with more or less 20 minutes long analysis with the spectroscopy, near a spectroscopy. So I can obtain an evaluation of the impurity level that is very important to the optimization of the preparation process that the material needs before to, for example, dyeing or finishing process. As you know, during the supply chain of the natural fiber, first of all, in particular with linen, when I have this raw material, I have to bleach the material, I have to clean the material with a chemical process that is very chemical, water, and time consuming. I can optimize this process, so I optimize the chemical, water, and temperature, for example, parameters according to the impurities. If a sample have a low impurity level, for example, if a sample is in this region of the graph, I don't need to push on the, for example, chemical amount or temperature during the process. If I have a sample with a high impurity level, of course, I have to increase the time, temperature, or chemical concentration. So if I have a predictive analysis that can give me an evaluation, of the amount of impurities in the sample, I can optimize the process. And with CHEMOMETRICS, with this model that we developed during the ATF project, I'm able to predict the amount of impurities without use traditional and time-consuming, let me say also, not so cheap chemical classic approach. This is just an example. Another example is what you can say in this slide. Here we have another model where I have different cluster, where the difference between the cluster, among the cluster, is the processing step. So we have here linen at the different processing step, starting from the raw wick. Wick is a particular step of during the processing of linen. So I have this first raw wick, then the first pass wick, step wick, the fifth step wick, then the bleached wick, and then the bleached yarn. So if I move from top to bottom, I move along the chronological, let me say, supply chain during the processing, the preparation of linen. So the model is able to create a different separated cluster for each processing step. So, for example, if I analyze an unknown material that I don't know, well, in this case, I know that it's a bleached wick, but the system doesn't know. So if I analyze an unknown sample and then I elaborate the result from the spectroscopic analysis with the chemometric, the system is able to put in the three-dimensional space the sample near to the cluster that is the same of my unknown sample. So also in this case, I can make a very simple analysis of an unknown material, again, more or less 15-20 minutes of an analysis, and I can have an idea of the nature of the sample. Let me say that, of course, the different steps are related to different impurity levels of the material, because if I move from the raw material to the bleached yarn, of course, the impurity level decreases, and so the relative cellulose percentage increase. So with this kind of analysis, I can have again an estimation, okay, an estimation of the amount of impurities or cellulose inside the sample, and it is important for the optimization of the subsequent processing step, but also can be used, for example, if I can predict the amount of cellulose, I can also have an estimation of the quality of the material, because higher amount of cellulose means higher quality of the natural fibers in this case. So during the ETF project, but consider ETF just an example of what I can do with the chemometrics in textile, I can develop a prediction approach of impurity levels of raw textile materials with, I repeat again, with a not time-consuming and a very cheap analysis against the normal time-consuming and expensive chemical analysis. This helped me to optimize the treatment process according to the predictive analysis, of course, so I can reduce energy, water, chemicals. Of course, I reduce all the environmental impacts that are related to energy, water, and chemicals use. And of course, it's also cheaper. That is a very good thing, I think. Okay. What we found during the ETF project, that the chemometrics approach can help us also in this case, coupled with spectroscopic near-infrared techniques. I can also have an estimation, an idea of the geographical origins. Let me explain. We analyzed different lots, production lots of cotton coming from different geographical area, and of course, at the same processing step. So the only difference was related to the geographical origin. And we have a good separation in the three-dimensional space of the different clusters that were related to the different geographical area. In this case, the model was not so performed or so optimized as the previous one, but it's just a very interesting suggestion about the future possibility when we use chemometrics, also with the traceability of textile, that if the people that work in textile very understand and know very well the problem of traceability of textile material. And of course, as I already say, the ETF demonstrates us that also the quality control can be obtained by the chemometric approach, because I can predict, I can have an estimation without, I repeat, the chemical analysis of the cellulose level and so the quality level of the material. So after this example that was aimed to give you a suggestion of what I can do with the chemometrics, I just want to give you potential for future perspectives of this approach. Maybe, as my colleague previously indicated you with the React project, they are trying to use chemometrics approach to have an estimation, a predicted analysis of, for example, the presence of chemicals on the textile material, but not only as contamination, but also as treatment. In the React project, of course, they are trying to evaluate with this approach the presence and the removing efficiency of the approaches that they are developing, to evaluate the amount of chemicals and the efficiency of the removal treatment of the chemicals. But I can use this approach, for example, to evaluate the contamination of textile, for example, at the end of life. So this approach, of course, in combination with the fiber composition that can be, of course, obtained thanks to the near approach, I can have a very good help for example, the sorting or the quality control of materials. A very important aspect that I wanted to stress that is that the chemometrics is very easy to automate, is automatable, because is based on a spectroscopic analysis and then an elaboration by computer science. Is very fast and is not destructive. So I don't have to pick up a piece of textile and destruct it with solvent or other possible destructive approach to extract the amount of chemicals and then analyze the chemicals with, for example, mass spectroscopy or other techniques. I just have to put a piece of textile in my spectrophotometer, then transfer the spectra to the chemometric model, and then just wait for the result. As I said, I can use chemometrics for the traceability, because I can trace the production phase, but also the use phase or the end-of-life phase of the material. I can, and this you can see here a question mark, because this is just an idea that we are working on, the possibility to use chemometrics to discriminate between recycled and non-recycled material, textile material, of course, because if this process modify some chemical, physical, or other properties of the material, if I have, as you can see in the last point, if I have a technique that is able to measure this changing in chemical or physical properties, then I can try to elaborate all this data that come from this technical analytical approach with the chemometrics, and maybe I will able, for example, to discriminate between recycled or non-recycled materials in textile. That again, people that work in textile know that during the last years, textile sector is working a lot on the possibility to identify and to trace recycling material against the non-recycling material. So we think that can be a very good approach, the chemometrics techniques also in this case. And that's all from my side, and I thank you for your attention, and thank you again to React Project.
Thank you, Omar, for your I think very clear presentation in order to give drive us into the chemistry, the chemometric of chemistry. Yes, and also thanks for the trailer for the next workshop that we'll have in the next months about the results of this approach applied to React object, that is auto recycler moving chemical finishing auto recycler acrylic fabrics. Thanks a lot. Thanks a lot also to other speakers. I think that the audience had or has a clear overview of the objectives, the challenges, the results that we are obtaining or we expect to obtain. Then is the time for question and for answer in case of question, of course. Waiting for some others from the audience. I can ask. I follow the sequence of the speakers. So I start with Daniele. Daniele, a question that often is in the thought or is asked for people where we talk about the REACT project and its activities and goals. The recycled material is the same. Is it the same of the Virgin one, or better? Do you know if recycled material maintains the same properties of the Virgin one? What you can say us about this? Which kind of material we will obtain from the recycle in this way?
For the acrylic at the moment, we don't have idea, because the mechanical recycling of acrylic fiber is an innovative approach. Usually the mechanical recycling of plastic is a downcycling, so the performance is not the same, but is lower. We will consider the possible change of the performance of fiber after the recycling in the project. The goal is to reuse the recycling yard to produce awning, but if the performance are lower for this use, we will evaluate the possibility to use the recycling acrylic fiber for other application.
Okay, thanks. Yes, we have started just a few times ago, few months ago, to make some test on recycled material, the first steps of the recycled materials. Yeah. So we'll have in the next months more precise results about the quality that we'll obtain from this complex recycling process. Yeah, this is it.
I can maybe
okay.
already.
Yeah, please, Joseph.
Yeah, I can already maybe comment on Daniele. That's for the chemical treatments. Until now,
Yeah.
we already know that it doesn't influence the mechanical properties.
Please, please. Sorry, I was unmuted. Okay, thanks, Josephine. I cannot see any other question for Daniele, so I shifted to Josephine in the sequence of presentation. So, Josephine, I have two questions for you. One is coming from the audience. So, please give us some more information regarding the improvement, of heat resistance due to the thermosetting resin.
Yeah. So I can detail this a bit more. So the thermosetting resin, it mainly gives dimensional stability. So it makes sure the fabrics maintain their dimensions, but also when the temperature increases. So for the fabrics for awnings of umbrellas, these will not shrink when they heat in the sun due to the dimensional stability given by this resin. So that's mainly what I meant with this heat resistance and dimensional stability.
Okay, thank you. Okay, I cannot see any other question, but I have one, as I said. Yes, perhaps with your this previous question, perhaps I can add another one, but you talked about owning finishes, because owning is one of the products of the React projects, of course, that we are studying. But do you think that the same methodology can be used for other types of waste?
So the other types of wastes are the coatings, the waterproof coatings, and the furnishing finishes. So the chemical composition of these finishes is different from the awnings, and we mainly focused on the awning finish, but the optimized protocol was also tested on the other fabric types. And in parallel to our work, the group of Professor Giuseppe Rosacci from Bergamo performed also multi-step removal processes, which were effective as well. So we obtained quite promising results for the 3 different types of fabrics, which are within the scope of the REACT project at lab scale level.
Okay, thanks, thanks, Josephine. Also, because you remembered me that I forgot the University of Bergamo, that really is not a partner, a formal partner of the REACT project, but as Centro COT, we are working together with the University of Bergamo in several projects. One of these was the ETF that Omar presented, but also they are involved also in the REACT project. So thanks for this help to me in order not to forget a very important, let's say, partner of our project.
Roberto, sorry to cut in. Yeah, I don't know, probably you've seen them already, but we have a couple of questions from Josephine that came from the audience.
Yes, now say okay, please, Galileo, go away.
Okay,
yes.
Shall I ask the question? Yeah, the first one from the audience is about how is it possible to remove thermosetting resin from finished textile?
Yeah, it's I cannot give the details yet about the chemical process we used, since this work is not yet published. But the details about these chemical process will soon to be published by our research group.
Okay, so basically, if you're interested, please stay tuned to our website. At the end of the webinar, I will post the link again, so you can have a look at the updates there. Another question, still from the audience, it's regarding the abrasion resistant of outdoor acrylic fabrics after mechanical recycling. Did you measure abrasion resistance before and after mechanical recycling?
No, we didn't measure abrasion resistance, and the mechanical recycling is not yet done. So what we measured was we measured with the Varimat tensile properties, mechanical testing of our fibers before and after the chemical treatment.
As I said during the presentation, we are in the middle, more or less, of the REACT projects, so we are still developing the suitable method to remove the finishes. Then the objective of the project is to have also some prototypes made by recycled materials, and then of course we'll measure, we'll test chemical and physical, in particular technological characteristics, in order to understand if the recycled material is usable for the same application or for other applications. So we imagine that, as one of our speakers said, that of course mechanical recycling is stressing the fibers, so perhaps we can expect to have less, let's say, characteristics as regards the virgin ones, but we have to test and to evaluate. This sure will be phase that we'll made in the next months, when we'll have defined, let's say, the removal process. I think that is, if any other of my colleagues or the partnership want to add something, is free, of course, to.
We have a more open question from Project Officer Kukulis on open to everybody, which is how can the results of your work be used to provide input to design the products better, so as to be able to recycle them easier?
Who wanted to answer? I try to myself. One of the objective is to also to identify the best, is to identify the best way to remove and to treat the finishing. Of course, not to study new finishing, but I think that in this case we can have some suggestion from the removal and treatment of sludge from removal, and perhaps we can, in our, if you remember, I said a recommendation at the end of the project, we can give some suggestion how to improve the finishing. I don't know if Andrea or Daniele or Omar are able to or want to add some words to my very general answer. Andrea, Daniele. We are not obliged, but please, if you have not to add, say I have not to add, or okay.
Okay, Mr. Vannucci. No, I think what you have explained should be okay for me.
Okay. Thanks. I don't know if.
May I add some notes, some information? I'm Ferrari. I am in charge of research and development in Para. Thank you to all for your presentation. And I would like to add some information, and I can try to answer the question to Johannes regarding the fact that if the result of this work can help us to design a better way to recycle the acrylic fiber. We are studying now the different process and the different step and the different order of the step to obtain the good yarn, and so to obtain also a fabric with feature, chemical and mechanical feature enough to have a fabric for awnings or for furniture. And we can also, we are studying also the new finishing in order to improve the abrasion resistance, but not only the finishing, also the process. I don't know if this information can help you to better understand the challenge and the final goal of our project.
Okay, okay, Barbara, you have also post your answer in the chat. Thanks for your comments. Yes, thank you. Okay, I don't see Galileo help me, but I cannot see any other until now any other question or comments by our audience. Okay, I have a question for Andrea. Do you know, from your point of view, you are providing technology, chemical technology, treatment technologies to your customers, of course, and this is your work. Do you know that there is, if there are any industrial processes well established or in developing for the removal of surface treatments, such as coating, for instance?
Okay, Mr. Vanucci, thanks for your questions. So remove coating from surface of fabric is a really particular operation, which needs to consider different points. For example, temperature, pressure condition, and selected chemicals to remove depending on finishing presence on the surface of fabric. From my point of view, the most important things is working by mechanical action to link each function to the chemical involved and selected. So an option will be to proceed by treatment in industrial machine, as explained with the mechanical action, for example, an industrial washer extractor. So it's really, really important to link chemical selected, right, to mechanical action. So doing this, I think we could get great results. Okay.
Thanks, Andrea. Yes, that's okay. So from the audience, another question for Josephine. What are the worst substances to remove that you found on finishings? Fluorocarbon or thermosetting resin? So which are the problems, the biggest problems you faced, Josephine?
So for the awnings, yeah, for the easiest to remove was the thermosetting resin, and for the fluorocarbons we had more difficulties to remove it, but this was mainly because we had some more difficulties with the characterization as well, because we always saw some traces of the fluorocarbons in our infrared spectra, but then via qualitative tests or oil repellency tests, however, they showed that fluorocarbons could be removed by our processes developed by us together and by the partner of the University of Bergamo, Professor Rosacci.
Okay, thanks. I hope that your answer is explicative for our participants. Okay, I have I'm looking for other question, not yet until now. No others, better. I have a question to Omar. So in order to have a wide presentations. Omar, phthalates are known plasticizer that are also used in textiles, and according to regulation, they must be absent or below a certain concentration. So it's, let's say, harmful substances. Is it possible through near spectroscopy together with chemometry to detect, is it possible to detect the presence of these substances?
Well, I don't have direct evidence about this, but I think yes, because as said during the presentation, if you have something chemical or not chemical that change in the material, and you can detect these property, in this case, the presence or the amount of a compound, phthalate, in this case, plasticizer, and so on. If you have a technical approach that can measure it, and there is also the near infrared spectroscopy, you can pull a lot of data and then try to elaborate, to treat this data with the chemometrics approach. So I think that is possible. We can see the phthalate like the impurities or cellulose that is spoken about. So I think that the answer maybe is yes.
Okay, thanks.
Thank you. You're welcome.
And yes, so we, as you can hear, we have some idea or some ways that are open to us, and then we can try to have different tests or activities. I don't know if we'll be able in the React, but as our partners for Martel, our partner for Martel, invite you to follow us in the our website that where we regularly update our news, our results. Of course, the information that we can share, because in some cases there are some confidential aspects that must be for a time be kept, be secure. There is a question for Andrea Cataldi. You can read it in the chat, but when you wash under pressure frayed acrylic with liquor, what do you mean for liquor? Soaps or more aggressive chemicals? Okay, Andrea, if you...
Okay, it's clear.
Yes, okay, that's clear.
Okay. Ada, thanks for your question. Liquor ratio, it means the ratio is not intended like soap or aggressive chemicals. No, it means the ratio between the material needed to be treated. So, for example, 10 kg of wasted acrylic. In liquor ratio 1 to 5, it means 1 kg of wasted acrylic, or 10 kg. It needs 5 more times of bath, of treatment bath. So 1 kg, 5 kg of bath, 10 kg, 50 kg. Okay, it's a ratio between kilograms of material and bath, quantity of bath. Okay.
And okay, thanks, Andrea. It means that you use the liquor in function of what do you want to remove or the results that we have from the study from University of Ghent or Bergamo, or so the study of reactor projects. Okay, thanks. I don't know if we are just arriving to the end of our workshop. I don't know if Yannis, I see that he has no, the microphone able. If Yannis want to add something or not?
Thank you very much. It was very useful, the workshop, and a very triggering a lot of questions for all, and I think it was very informative. I'm covered with my question already, and I'm looking forward to the results and on our next meeting or the next occasion to have a public discourse on the results of React.
Of course, thank you. Yes, sure. If I remember well, we still so we have to held at least other 2 workshop or webinar like this in the next half time of project. That means 18 months. And but of course, if you will have results, whatever results we will be very interested in showing to the technical and scientific audience that we can reach, of course. I ask if the last time, if you have any comments, even no, or if not the case, I ask to Galileo or Margherita from Martella if they want to add something. So if they have some technical issue to be shared with our participant, even though if not the case, we can close this webinar. From my side, I thank you all, the speakers, the project office.
Okay,
and
just a question.
Sorry, please. Sorry.
Okay,
Sorry,
but the slide, could we have a copy of slide? Thank you for all. We have the copy of slide?
Yes, the slides will be, all the presentation will be uploaded in the website of the React project. In the chat, you can read the link that is quite simple, the www.react-project.net. So reactproject.net. But I think that you can read in the chat and you can find, I don't know, perhaps one day or today, I ask to Galileo when the slide will be available on the website. Please, Galileo or Margherita.
Yes, we indeed are planning to make the slides available as soon as possible on the website. All the attendees will be also sent an email containing a link to the slides and to the recording of this webinar.
Okay, thanks.
Okay, thank you. Thank you.
You are welcome. From my side, again, I thank you all, and see you next time. And follow us on the social media that you have seen during the presentation of the speakers. Thanks. Thanks, many thanks to all.